Hi, so this is video number 2. We're going to go through the exam question. We've had to swap up a bit because of the light in the room. So Charlotte's on that side, I'm standing up. I've already gone through this one, so I've marked on all my mark points, so I'll have to talk you through them. Okay, so question 1. First thing you should have had marked off is the myelin sheath up on the motor neuron like that. Give it a tick. Second question. Asked about newborn babies having slower reflexes without a myelin sheath. So you've got to have no saltatory conduction. Without the myelin sheath, the action potential cannot jump between the nodes, so the whole axon membrane has to depolarize, giving a much slower conduction speed for nerve impulses. That would be a good answer for 2 marks. Part B. Now this question is in 2 parts. We've got the neuromuscular junction and the shortening of the sarcomere. Now you would never get this on the new spec on paper 2 because it's too many mark points, but you could get the first half or the second half as a 3 or 4 marker. So it's worth doing and it's worth consolidating everything together. So the first mark point is for action potential arrives at the end of the motor neuron, causing calcium 2+ to diffuse into the motor neuron. This causes vesicles containing acetylcholine. Now you would have to write that in full for the full mark, to fuse with the membrane, releasing the acetylcholine, this is exocytosis, into the synapse. The acetylcholine then diffuses across the synapse and binds to complementary receptors in the sarcolemma, so in the cell membrane of the muscle cell. Okay, so that's where that mark point would be, for binding to the receptors. Whether there'd be an extra mark point for this, I don't know. But what happens is that sodium moves in by diffusion, depolarizing the membrane. Okay, that depolarization spreads rapidly down the T-tubule deep into the muscle cell. And when it arrives at the sarcoplasmic reticulum, it causes calcium ions to be released from the sarcoplasmic reticulum. You won't get the mark just for that. You have to say release from the sarcoplasmic reticulum. Can you get that now? Is that in the light? Into the myofibril. Okay. So now we're moving on to what happens in the muscle to bring about the contraction. So you'll be able to see your mark points here from your keynotes. So the calcium 2+ binds to the tropomyosin. It changes shape and uncovers the myosin binding sites on the actin. That's your first mark point. Now the myosin can bind to the actin, so it forms cross bridges. As soon as it does that, it's got energy already in its head. It nods, using the energy released when ATP has been hydrolyzed in the head. So you'll get a mark for binding and a mark for nodding. This action of nodding pulls the actin, sliding it further over the myosin, increasing the overlap between the 2 myofilaments. ATP binds the myosin head, that breaks the cross bridge, that would be 1 mark, and returns its head to the original position, and then the cycle repeats. Okay, brilliant. Thank you. Right, so